Government Polytechnic College for Girls, Jalandhar, and I am here to discuss in the subject consumer electronics and in particular television camera tubes. So, in consumer electronics as we deal with the audio and video systems. So, while dealing with video system, the television camera tube is a very essential tool of the video system, because it is the basic building block on which we capture the picture, and only if we can capture the picture, only then we can transmit and receive the picture. So, camera tube is a very essential and integral part of video system. Under this heading, we will cover the following topics. One, camera tube, what the camera tubes are, then basic principle. There are various types of camera tubes, and these camera tubes operate on different principles. So, we will discuss the principles of each of the tube, and then the types of camera tubes, what are the various types of camera tubes and how do they work. So, television camera tubes. An electron tube use a light sensitive material or receptor that converts an optical image into an electrical television video signal. So, this is the basic purpose of any camera tube, that it converts the light information into electrical signal or video signal. The tube is used in a television camera to generate a train of electrical pulses representing the light intensities present in an optical image focused on the tube. So, whatever the image is focused on the tube, what are the light information and what are the various reflections from the various areas of a particular picture, that is captured with the help of camera tube. Each point of this image is interrogated in its proper turn by the beam in tube, and an electrical signal corresponding to amount of light at that point of the optical image is generated by the tube. This signal represents the video or picture portion of a television signal. So, what the actual television signal is, that whatever the scene is being focused on the camera tube, what is the brightness level reflected from a particular point of that scene is reflected on the face of the camera tube, and depending upon that light intensity, a corresponding electrical signal is generated, and that electrical signal is considered to be the video signal corresponding to that particular area of the picture. Basic principle. Camera tubes work on the two principles. One is photoconductive effect and second is photo emission effect. Now, we will discuss one by one what the photoconductive effect is and what the photo emission effect is. First, photo emission principle. Certain metals emit electrons when light falls on their surface. So, certain metals they exhibit this property, that whenever light falls on their surface, they will emit some electrons. These emitted electrons are called photoelectrons, and the emitting surface a photocathode. As these electrons are emitted because light falls on that metal or that particular area of the metal. So, that is why these electrons are called photoelectrons, because they have been emitted due to presence of photons or due to striking of photon on that particular area of the surface, and emitting surface a photocathode. As light falls on the that particular surface, electrons are emitted from there. So, wherever the electrons are emitted from, that is called a cathode, and because these electrons are emitted because the photons strike on that particular surface. So, that surface which liberates electrons due to emerging of light on that particular area or that particular material, that is why it is called photocathode. Light consists of a small bundle of energy called photons. As I already have explained, light consists of small bundle of energy, because light is not a continuous process, it is a discrete process also. In this we have packets of photons, energy packets, which are called photons. So, those photons are basically the light particles. When light incident on a photocathode, the photons give away their energy to outer valence electrons to allow them to overcome the potential energy barrier at the surface. So, actually what happens, how the electrons are liberated, that is very important, because electrons are present in the molecules and they are considered to be revolving around the nucleus. So, when light falls on the surface of a particular material, which we may call the photocathode or photoemissive surface, then what happens, the as we say, photons are energy particles or packets of energy. So, when photons strike on the surface of that particular photoconductive material, photoemissive material, then what happens, the energy contained in photons is transferred to the molecule of that surface, and when energy is transferred to that molecule, because it goes into the excited state, and due to this the electrons present or electron revolving around the nucleus, which are in the outermost orbit, they are excited, and due to that energy they they jump from that energy level to the conduction level. So, that is why they are emitted, they break that potential energy barrier and they become free to give away the free electrons. The number of electrons which can overcome the potential barrier and get emitted depend on the light. So, how many electrons will be emitted from a particular surface at a particular time, that depends upon the light. What is the intensity of light? Means light is energy particles. So, how much energy is being emerged into the nucleus, into the molecule. So, depending upon the light, depending upon the energy, the number of electrons vary. If more the energy means more the light, more will be the number of electrons which will be liberated. Alkali metals are used as photocathode because they have very low work function. So, work function is the energy required. What work function is? Work function basically is the energy required to liberate one electron from the outermost shell of a molecule and take it to the conduction level or make the electron free. So, to break that barrier, whatever the energy is required, that is called work function. Cesium silver or bismuth silver cesium oxides are preferred as cathode surface because they are sensitive to incandescent light and have spectral response very close to the human eye. So, these are some of the materials which are normally used as or preferred to be used as photocathode, because they are very sensitive to incandescent light and they have a very good spectral response which is close to the human eye. Next principle, that was first principle, photoemissives. The another principle is photoconductive principle. In some metal, when light photon fall on it, then its conductivity or resistivity change. So, this is another principle. In earlier principle, what we discussed, that when light falls on the surface of a photocathode, then electrons are liberated from the outermost shell of the molecule. In this principle, what happens, as it is written in some metal, when light fall on it, then its conductivity or resistivity change. Here the electrons are not liberated, they do not become free, but their resistivity or conductivity changes. So, this is the second principle. Semiconductor metals like selenium, tellurium and lead with their oxide have this property known as photoconductivity. So, this property of varying the conductivity or resistivity of a particular material when it is exposed to the light or the source of energy which is contained in the light, then its conductivity changes, because these are the photons. Whenever we talk about the light, these are the photons which are energy particles. So, when its conductivity changes due to presence of photons, then this property is called photoconductivity. The variation of resistance at each point across the surface of material is utilized to develop a varying signal by scanning it uniformly with an electron beam. Whatever is the variation in resistance at each point across the surface of metal, this is utilized in this camera tube, this particular principle, and this is used for scanning the particular area, because electron beam travel on the on the surface plate, and when electron beam falls there, then conductivity changes, as it has already been exposed to the source of light which is the scene. So, conductivity has already changed. So, what is the difference between the two adjacent conductivities or two adjacent portions of material in its conductivity, that is considered to be the signal. Now, the types of camera tubes, there are three basic types of camera tubes which we use. So far we are discussing the monochrome tubes. So, these three types are: first, image orthicon tube, second is vidicon, and third is plumbicon. We will discuss them one by one. So, first is image orthicon. So, in image orthicon, here we have the camera lens, here is the photocathode, these are the focusing coils, these coils are the focusing coils, these coils, the inner ones, these are the deflection coils. This particular beam is called scanning beam. Here we have alignment coil, this alignment coil is responsible for alignment of the electron beam. Then we have electron multiplier, electron gun, return beam, as beam strikes and then it comes back, it is return beam. This is the target face plate, this is the target screen, and these are the photo electrons, these 3 electrons as are shown here, these are the photo electrons which fall on the target screen. So, whenever this is exposed to the source of light, whenever this target plate or target screen is exposed to the source of light, then light travels through this camera lens, as all of you might have seen those camera tubes. So, we have a lens which is used for focusing a particular scene. Suppose here is some particular scene. So, the focal length is so adjusted that the clear image of that scene is made to fall on the target screen. So, when that image, once it is focused, then that light reflected from the target or from the scene will fall on the target screen, and these are the 3 photo electrons, means electrons which are liberated from here from the photocathode, and they fall on the target screen. There are 2 layers, one is photocathode and one is target screen. When light falls on photocathode, then what happens? From here electrons are liberated and these electrons travel to the target screen. So, when they strike at the target screen, what happens? Here how many electrons have been liberated, that is known by scanning the target plate, target screen or target plate with the help of electron gun. From electron gun, electrons are liberated and these electrons travel under the effect of 3 different coils. What these coils are? First, alignment coil, this is responsible for alignment of electrons. So, electrons should be kept aligned throughout its journey from electron gun to the target screen. So, this is ensured with the help of this alignment coil. This is the cross sectional view of the tube, image orthicon tube. So, as I have shown this by the dotted these crossed lines. So, this is cross sectional view. So, this alignment coil is wound around the tube here. Then we have the deflection coil. So, deflection coil is the coil in which the current flows and the electron beam travels under the effect of deflection coil. So, this deflection coil is responsible for deflection of electron beam from left to right and from top to bottom. So, there are two coils, one is horizontal deflection coil and second is vertical deflection coil. So, these two coils are wound around here, and under the effect of these two coils a force will be exerted on the electron beam, which will make this electron beam to travel from left to right while scanning horizontally and to travel from top to bottom while we are going for vertical scanning. Then we have focusing coil. So, purpose of focusing coil is to keep the electron beam focused on the target screen. As we know, electron beam is a cylindrical type structure. When there are so many electrons liberated from the electron gun. So, when these electrons are liberated, they travel in the shape of a cylinder, but when our purpose is that when they strike the target screen, they should strike in the form of a point, means all the electrons present in the electron beam at a particular instant, or all the electrons which are liberated from the electron gun at a particular instant should strike the target screen at once. So, this should strike in a point form. So, this is ensured with the help of a focusing coil. Now, we will discuss how it works, the principle of photoemissive which is used in image orthicon. It has three sections: image section, scanning section and electron gun cum multiplier section. First is image section. Image section consists of glass plate coated with silver antimony, which serves as photocathode. As I discussed earlier, photocathode is something which liberates the electron when photons strike on the surface. So, silver antimony is the material which is used for photoconductivity or photocathode. Then lens assembly: light from the scene to be televised is focused on the photocathode surface by lens system. What we call focusing of the particular scene means that a scene should be clear and it should be at the focal length of the lens. So, this lens is used to focus the image of the scene on the photocathode. Photocathode surface is semi transparent and light rays penetrate into reach its inner surface where electron emission takes place. So, this is important. Photocathode surface is semi transparent, light rays penetrate. So, light rays which are nothing but the photons or energy bundles, they penetrate through this because this is semi transparent, and after penetration they reach the inner surface where electron emission takes place. When photons strike at the inner surface of the semi transparent photocathode, then emission of electrons take place. Target plate: when electrons emit from the cathode, it cannot store charge being a conductor. When electron is emitted from the photocathode, the charge cannot be stored because it is a conductor. For this reason, the electron image is made to move toward the target plate located at the short distance from it. As I showed you in this slide, this is kept at a little bit distance from the photocathode, the target screen. So, these electrons which are liberated from the photocathode, they travel to the target screen. The target plate is made of a very thin sheet of glass and can store charge received by it. This is maintained at about 400 volt or more positive with respect to photocathode. As the photocathode is a conductor, it cannot store charge. So, those electrons which are liberated from the photocathode, they are made to travel to the target screen where when they reach the target screen, because it is kept at a positive potential with respect to photocathode. So, these electrons will merge into that target screen and they will be stored there. So, that charge will be stored there on the target screen. When electron move from cathode to target plate, there is a chance that it may repel each other. This can result in distortion of information available as charge image. So, this is something which has to be taken care of, that when electron move from cathode to target plate, there is chances that it may repel each other due to the same charge, because they are negatively charged particles, and this can result in distortion of information available at charge image. To prevent this divergence effect, an axial magnetic field generated by focus is employed. This is called focusing. So, all the electrons are made to travel in their own line. So, they are made to travel linearly, so that they do not interfere with each other, or they do not repel each other. They cannot attract obviously, because they are similarly charged particles. So, the only chance is that they can repel each other. So, that is ensured that they do not repel each other and they strike the target screen as such. This magnetic field impart helical motion to electrons and focus them on target plate. The image side of target plate has coating of cesium that emits secondary electron. These secondary electron is collected by wire mesh, which is located at front of target plate. So, for this I will have to move back to slide number 10, where this little mesh is shown. This is that little mesh. Here when electrons strike here, there are all chances that there will be a secondary emission of electrons. This is the electron emitted from this photocathode is nothing but primary emission. So, these emitted electrons, when they travel like this and strike here at the target screen, while striking at the target screen, they have got some energy with them, and due to that energy there are chances that some electrons may be liberated from this target screen. So, these electrons liberated from the target screen are called secondary emitted electrons. So, this secondary emission is avoided by providing a mesh just in front. This is these dotted lines, this is the mesh. So, this mesh is responsible for prevention of secondary emission of electrons. The positive charge appeared on target plate is proportional to the light intensity distribution on photocathode. What is the intensity, what is the amount of positive charge at a particular particular area of the target plate? It is proportional to the light intensity distribution on photocathode. What is the light intensity at a particular area of the photocathode? Depending upon that, the positive charge will appear at the target plate. Second section, scanning section. Fine electron beam, it scanning section is the section which is used to ensure the following things. One is fine electron beam, second is focus and alignment coil, third is deflection coil, then horizontal deflection and vertical deflections. As I told you earlier, deflection coil consists of two coils, horizontal deflection coil and vertical deflection coil. Electron gun assembly and multiplier, it consists of electron gun and multi-stage electron multiplier. So, electron gun is something from where electrons are generated, and this multi-stage electron multiplier is, this is how the electrons can be multiplied. Now, we will discuss the second tube, that is Vidicon. We will discuss its principle. Its principle is photoconductive, as the principle of first was photo emission, its principle is photoconductive. It has three sections: target section, scanning section and electron gun. This is the assembly of Vidicon. here we have the target. This is the glass face plate which we normally see when you see a camera tube or a camera. We see at the front, that is glass face plate. Just after this we have target, and then we have various grids. This is target connection, how the target is connected, those particular leads for connection. Then we have different coils, as we discussed in the previous section. Focusing coil, these coils are responsible for focusing of electron beam. Horizontal and vertical deflection coil, these two coils, the inner coils, these are horizontal and vertical deflection coils. Then we have alignment coils. Here is grid number 1 and grid number 2, and here is grid number 3. So, these grid number 1, 2 and 3, what these grids are, and we will discuss them. This is cathode. So, when we give supply to this tube, this cathode is excited, and when it is excited, the electrons are liberated from the cathode. Cathode is something where electrons are liberated from. So, when electrons are liberated, we have two grids, grid number 1 and grid number 2. The purpose of these two grids is we say it is a control grid. One is control grid and second is accelerating grid. In control grid, what we have, we control the velocity of electrons. So, when electrons are liberated, first they are made to travel at the same speed, electrons are made to travel at the same speed, and then they are accelerated by using these grids. Here we have alignment coils, as we discussed in the previous section. Alignment coils are the coils which keep the electrons aligned throughout its journey. So, electrons are aligned with the help of alignment coil. Then we have focusing coil, which is throughout, we can see that this right from the beginning, it is till the end of the tube. The purpose of this focusing coil is that it keeps the electron beam focused. As we can see from here, this electron beam is little bit scattered while it bends away from its mean position. Because why electron beam bends? Because we have to scan the different areas of the target plate. So, electron beam has to travel to the various parts of the screen or the raster or the target area. So, for example, we can say that it will start from the top left hand corner. So, it has to be deflected in such a position that the electron beam should be at the top, it should be attracted towards the top, right. Here if this is the face plate or target area, then it should be at the top, and then when we say that we have to scan the very first pixel of the section of the target, then it has to be at the extreme left hand corner. So, top left hand corner is pixel number 1. So, when this is selected or scanned, then electron beam has to move to the next pixel. It means the potential or the current in the deflection coil, that will remain same in vertical deflection coil, but it will vary in the horizontal deflection coil. So, it vertically it will remain at the top position, but horizontally it will travel toward the right, from left to right, pixel number 2, pixel number 3 and so on. It moves from one pixel to another pixel and so on. So, when it reaches at the extreme right hand corner, it has to travel back. So, then what happens, the direction of current in the horizontal deflection coil is reversed. So, under the right to left, and at the same time what happens, there is some intensity of current which enables this electron beam to come down from top to bottom. So, it travels from extreme top position to little bit downwards. So, that is why it is able to scan the next line. So, again the same process is followed. The current in horizontal deflection coil keeps on varying, so that the electron spot or beam spot can move from left to right, but the current in vertical deflection coil remains almost same, though it varies little bit. So, that it comes down little bit, because these scanning lines are not perfectly horizontal, they are little bit inclined downward. So, it is able to scan the next line. So, this is the purpose of these various coils being here, and